All right, this is Miss Triangle with the 3-5, section 3-5 video. It's kind of a dense one, so we'll do our best. Please make sure you're putting the date and the title, 3-5 parallel and perpendicular equations, and feel free to abbreviate parallel and perpendicular if you would like. Set up your lines for your Cornell notes. And you're going to start with your essential question. How do you write equations for parallel and perpendicular lines? So this will be somewhat review from last year when you were in algebra, but I know that it's been a while. Then we're on learning target 3B. You might have noticed that we kind of missed 3B. In previous years, we did this section before other sections, so that's kind of why it's out of order. I can use my knowledge of slope to solve problems and write equations for parallel and perpendicular lines. So feel free to pause the video to take more time to write any of that down. All right, next, we're going to write in the question on the side. What are the three forms of linear equations? So you studied these last year in depth. What are the three forms of linear equations? And we're going to go over those. I also want you to write down our first vocabulary word, slope, and highlight it, slope. Then please make sure you're writing all of this down. So what is slope? Slope is the steepness of a line, like a ski slope. Is it a black diamond, a blue square, whatever? How steep is the line? It is also rise over run. And the formula is m equals, slope is the letter m, I'm not sure why, but slope is m. M equals y2 minus y1 divided by x2 minus x1. So pause the video, make sure you have all of that written down. Hopefully it sounds like review from last year. All right, let's get into the three forms. So the first form of a linear equation is called slope-intercept form, and it's y equals mx plus b. I put it in a box, y equals mx plus b. So this is the most common form. It should look familiar. As an example, the m and the b are going to be numbers. So above that, I wrote y equals 2x plus 4. That's kind of what the actual equation would look like. So m is the slope, b is the y-intercept. That's why it's called slope-intercept. All right, then I put a plus for kind of a pro to this type of form. A pro is that it's easy to graph. That's partly why we use this. It's super easy to graph. You graph the y-intercept, you count your rise and your run, you're done. A con or negative, that's why there's a minus, is there's kind of a lot of steps to writing the equations. There's about 3 steps. All right, so make sure you have all of that written down. The next form is called point-slope form, point-slope form. And I'll put a box around this. Here is your formula. Y minus y1 equals m. M is still slope. X minus x1. So it's called point slope because there's slope, and then the x1 and y1 are replaced by the x and y values of a point. So if you kind of look down here, this is an example of what the equation would look like. Y minus 5 equals 3 parentheses x plus 2. That's what the equation would actually look like. So a plus of point slope form is that it's super easy to write the equations. A con, and we actually don't use point slope form too frequently, is that it's harder to graph, it's harder to make tables, so we don't always use this super frequently. All right, the last one is called standard form. And part of this got cut off, so I will kind of write some of this in. Standard form is ax plus by equals c. Ax plus by equals c. If I was writing that in with numbers, the a, b, and c are numbers. So my example that I wrote was 4x plus 2y equals 1. Hopefully you're kind of noticing this looks a little different. I put a star because it's very important, a star right here. There is no slope or m in standard form. There's no slope or form. Or m. So a pro is it's super easy for intercepts. If you're trying to find the x and y intercepts, it works really well. It also works great for word problems and system of equations. A con, a negative, is that there is no slope. And a lot of times we want the slope. So please pause the video to get any of the notes that you need or need more time. All of this should be written down. It's kind of condensing like probably a couple months of last year's learning into one slide. All right, here's the first example. So I want you to copy the question, copy this question. How do you partition a directed segment? You'll definitely want to write all this down and probably watch this example twice. So find the coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3:2. And then just sketch the graph. So just kind of sketch it. You want to put A at 3,2 and B at 6,8. So we don't know exactly where, but point P is going to be somewhere on this line. All right, and notice they use the word directed line segment, AB. That means that the direction does matter. We are traveling from A to B, so that the ratio is 3:2. All right, so how are we going to do this? My first step is just to think about how many parts do I have. So if you think about 3:2 right here, that really means there's a total of 5 parts. We're going to partition this line segment into 5 parts. Okay. Then point P should be 3/5 of the way. So point P is 3/5 of the way from A to B. So just if I was estimating, it's probably going to be like somewhere around there. I don't know exactly. 3/5 is about 60%. All right. So how are we going to do this? The first kind of mathematical step here that I'm going to do is I'm going to find the rise and the run. I'm going to find my slope, the rise and the run of A to B. So A, I'm going to write it a little bigger, is 3,2. That's x1, y1. B is 6,8. x2, y2. My slope formula that I wrote down on the last slide is y2 minus y1 over x2 minus x1. So let's plug those in. y2 is 8. Minus y1 is 2. So 8 minus 2, I get 6. On the bottom, or the denominator, x2 is 6. Minus x1 is 3. 6 minus 3, I get 3. So my rise over run is 6/3. 6/3. Okay. Then to find the coordinates of P, I need to add 3/5. Okay, I need to find 3/5 of the run and add, so I'm going to add 3/5 of the run to the x coordinate. And just to remind you, here's the rise. 6 is my rise. 3 is my run. So I need to add 3/5 of the run. So my run is 3. So I'm going to do 3/5 of 3. That's 3/5 times 3. 3/5 times 3. I get 1.8. So I need to add 1.8 to the x coordinate of A. If I look at point A, the x coordinate is 3. So I'm going to do 3 plus 1.8. The x coordinate of P is 4.8. I'm going to go ahead and circle that, highlight that so I don't lose that. All right, I'm going to have to zoom out a little, give myself a little more space. I'm basically going to do the same thing for the rise or the y. So I'm going to add 3/5 of the rise to the y coordinate of A. So I'm going to do 3/5 times the rise. The rise up here is 6. So 3/5 times 6. You can use a calculator. I get 3.6. I'm going to add 3.6 to the y coordinate of A. The y coordinate of A up here is 2. So 5.6 is my y coordinate. So my final answer is 4.8, comma 5.6. That is where point P will be located. That's the point that is 3/5 of the way between A to B. Let's just look at our graph for a second and see if that seems reasonable. So 4.8, 5.6. 4.8, 5.6, yep. That's about where my point is. That is where point P is. All right, example 2. So just sketch the graph, okay, and we're going to determine which of the lines are parallel and which of the lines are perpendicular. So just to remind you, parallel lines, okay, parallel lines have the same slope. So parallel lines, same slope. Perpendicular are negative or opposite reciprocals. Something like 2/3, positive 2/3, and negative 3/2. So we need to find the slope of everything. So let's start with A. So A is the blue line right here. Let's find the slope of A. So you can certainly count the rise and the run, and they even put 2 points. It looks to me like the rise is 1, the run is 1, 2, 3. 1/3. Rise over run, 1/3. All right, then let's look at B. B is the red line. So the slope of B, I'm going to count the rise. The rise is 1. The run is 2, 1/2. All right, let's look at line C. So pause the video, it's green. See if you can figure out the slope of line C. So I am getting 1/2 for line C. See if that's what you got, 1/2. All right, and the last line I need, the purple line, is line D. So let's see, line D, it looks like I'm going down 1, 2, and over 1. Down 2, over 1. So negative 2 over 1. So let's start with parallel. What lines are parallel? Parallel should have the same slope, so that would be lines B and line C. So I'm going to write that out. Line B is parallel to line C. How do I know that? They both have a slope of 1/2. Negative reciprocals for perpendicular, negative or opposite reciprocals, that would be something like 1/2, and if I change 1/2, if I flip the fraction and I make it negative, that would be the same as negative 2 over 1. So line B is perpendicular to line D. And line C, since it has the same slope, is also perpendicular to line D. So here's my answer.